Hey guys, so this is a quick review for the Unit 2 quiz, which is coming up. Please make sure you pay attention to the procedures, you review these concepts well, pause, go back, and make sure that you master all these questions by the time this video is over. So let's get started with number one, which says, can you erase this one here? So it says, given the functions f of x equals 5x squared minus 2x plus 3, and g of x equals negative 3x squared minus 7, perform the following operations. So in part A, you're subtracting. You want f of x minus g of x. So what we do here is we write f of x, which is 5x squared minus 2x plus 3. And we're going to take away, we're going to subtract g of x, which is in parentheses always, negative 3x squared, and then minus 7. So this becomes 5x squared minus 2x plus 3. There's really not much going on with the first function f of x. Now the negative we know when distributed makes the signs the opposite of what they currently are. So this becomes plus 3x squared and then plus 7. And once you're here, you combine like terms. 5x squared plus 3x squared is 8x squared. And then negative 2x is the only term in x. And then 3 and 7 is 10. Remember, when you write a final answer, you write them in descending order from the highest exponent. The x here is technically next to the first power, to the lowest, and then a constant, okay? So this is basically the first answer. And make sure you box your answers, okay? Box or circle, just to identify that, okay, these are my steps here, and then this is my final result. Part B, f of negative 1 and plus g of 3. So we start with f of negative 1. F of negative 1 means take all the x's away and replace them by negative 1. So plug in negative 1 for x. And this becomes, remember, a good practice for plugging in a positive or a negative is to erase all the x's away, right? Replace them with parentheses in the equation, and then plug in the anticipated value here, okay? So this is what we do to kind of have make sure that the math is done correctly. And then when you square, a common mistake that I saw on the last assessment is that people would multiply 5 by negative 1 to get negative 5, and then they square the number. This is incorrect. Anytime you have a square or an exponent, the exponent always applies to what's to its left. In this case, it's applying to the negative 1 in the parentheses. So negative 1 squared first by PEMDAS, which is 1, multiplied by 5 is 5. Negative 2 multiplied by negative 1 is positive 2, and then positive 3, and the answer to that is 10. Similarly, for g of 3, you're going to replace all the x's in g by 3. Negative 3 multiplied by 3 squared, and then minus 7. Again, you do 3 squared first, which is 9, not 6, it's 9, careful. 3 squared is 9, multiplied by negative 3 is negative 27, and then minus 7, which is going to be negative 34. Remember, when you're subtracting negatives, the number becomes larger negative, right? You're adding more negatives, you're losing more, so you get a larger negative. And now finally, so these are the two kind of steps through, and then last step is to find the actual answer, f of negative 1 plus g of 3. So all you're doing at this point is adding 10, which is f of negative 1, and g of 3, which is, you can do plus negative 34, just subtract 34, right? And this will give you a negative 24. Now, once you get to a final answer, remember, it's a good practice to box or circle. Part C, f of x multiplied. This dot here is a multiplication. And by the way, speaking of multiplication, we can write that as f of x multiplied by g of x like this, or we can write it as f times g of x, right? These are the same thing, this and that. Very much like if we do f of x divided by g of x, or same thing is f over g, all that is of x, okay? So these are two things to say the same, and those are two things to say the same thing. So let's multiply f of x by g of x. F of x is 5x squared minus 2x plus 3. I want to multiply all that f of x, which is in parentheses, by a g, which is negative 3x squared minus 7. So we can multiply, we can do the method that we learned, first times first, first times second, second times first, second times second, third times first, third times second, and that will give us 6 arrows, which means we're going to get 6 different values at the beginning before we combine like terms. So this is what we're going to follow. I will erase the arrows, but at least you know what you're doing. So 5x squared times negative, or multiplied by negative 3x squared is negative 15 x to the fourth. And then next is 5x squared multiplied by negative 7, which is negative 35x squared. Then negative 2x, now it's this, right? Negative 2x multiplied by negative 3x squared is positive 6x cubed. And then negative 2x multiplied by negative 7 is positive 14x. And then lastly, the 3 is going to get multiplied by the 2 terms, which is going to give us negative 9x squared and then minus 21. And once you're here, you're going to combine like terms, starting again from highest to lowest. So negative 15x to the fourth is the only term that is an x to the fourth. Then we look to see if there's x to the third. Remember, we're writing the polynomials in descending order. That means the highest exponent, then the second highest, and so on. So I see 6x cubed. So I'm going to write this second here after the negative 15x to the fourth. And then x to the second, I have 2 of them. So I need to combine them first. And negative 35x squared minus 9x squared is negative 44x squared. And these are gone. Again, they're both negative. They give you a larger negative. And then copy down the positive 14x and then minus 21. And you're pretty much done. Okay, so this is how it goes for multiplying polynomials. And this is basically in a box. Okay, and if you have any questions, if you feel that, this is a little bit fast, go back, pause, and pace accordingly. Part D, classify f of x times g of x by degree. And this is important. This wording for this part is important. When we're saying classify by degree, we're asking you what's the name, right? What's the name? But before that, let's take a look at f of x multiplied by g of x, which is technically from here, right? This was f of x by g of x. What was the degree? This is what we ended up with, this polynomial. What is the degree? How do I know the degree? To find the degree of a polynomial, you look at the term with the highest exponent or highest combination of exponents. So here you have 1, 2, 3, 4, 5 terms. Well, we don't even care about the terms because we didn't talk about that. But the highest, I'm just saying to the highest, of the degree 4 is the highest, right? So how do I classify this by degree? The classification says by degree, this polynomial is known as a quartic. Quartic sounds like quarter, right? Like 1/4. So there's a 4 in it. Now just pay attention for a sec here. So if I were to say state the degree, if I were to say state the degree of right? In this case, you would say, what would you say? If I say state the degree, you would just say 4. The degree is 4. But when I say classify, that says what? Classify by its degree or by the degree. You would say the mathematical name for it. In this case, if anything to the 4th power, you would say what? Quartic. So in this case, we're asking for classify. That's why we end up not saying 4, but instead saying what? Quartic, the appropriate word for it. And it's in your vocab. If you remember the beginning of the unit packet, you had vocab, and this is one of them. So the second part here, or before the second part, still the second question of the first part, it says identify the number of terms. Here you go. So now we're switching it up. Now we're talking about number of terms. Identify the degree and the number of terms in the polynomial. So first of all, how many terms? Terms are easy to identify. Terms are the items that are separated by pluses. Okay, so here it's like saying this plus minus this, plus that, plus negative, right? So it's the items. Think about them as the items. So you have 1, 2, 3, 4, 5, 6 items. For this reason, to identify the number of terms, we would say 6. Now, how do you identify the degree? Because you have a polynomial with 6 terms, or any polynomial in this matter, you have to count you have to look at every term and look at the combination of the degrees from each term. So the 4 and the 3 here, then the 3 and the 2 here, then the 2 here, and then the 5 and the 4 here, and then the 2 here. And when you have a constant, constants are of degree 0, okay? So what are the degrees? What are the degrees when I look at them? Well, 5x to the 4th y cubed is degree 7 because I added the 4 and the 3, so the degree 7. This term has degree 7. This term has degree 5. This term has degree 2. This term has degree 9. This term has degree 2 again, and this term has degree 0. So which one has the highest degree? It would be this term. And therefore, the degree of the polynomial is degree 9, is 9. Okay, so that's how the degree of the polynomial works. Make sure you remember that. Let's move on to the next page. And the next page is pretty much factoring. So it says factor each completely, factor out the GCF first if necessary, and then if the expression does not factor, state prime. That means say it is prime. So factor each completely means factor until you can no longer factor, but before you factor, find out first if they have what? The GCF, if the terms have a greatest common factor. And if it doesn't factor, say prime. So let's apply this to number 1. With number 1, I see a greatest common factor. I see factors at least. I see a 6, an 18, and a 3, and I can see that 3 goes into all of them. And then I see m cubed, m squared, and m squared. M cubed and m squared and m squared. And I can take in common an m squared. Similarly, for n's, I have n squared and n, so n is in common. And then when I'm done doing this, when I factor the GCF out, then what is left? I'm left with 2m, right, for the first term. And if you forget, just multiply these terms, you should get this back. But do that later, right? Do that on the side and not here, because you don't want to confuse yourself. You're factoring now, you're not multiplying. So then minus, bring the minus down. 3 multiplied by what gives me 18? 3 multiplied by 6. I took m squared out of m squared. There's no more n squared. M squared. I took n out of n squared. There's one n left, or n left, I should say. And then 3m squared n times what gives me 3m squared n? It's times 1, times positive. So this is pretty much it. This is how this factors, and you can no longer factor it. You're done. So this is it. Okay. Now, number 2 says 28x to the 3rd plus 20x squared plus 21x plus 15. Now, if you remember in class, we stressed the importance of this. When you see 4 terms, you're likely doing grouping. So you're factoring the terms 2 at a time, right? 2 at a time. So in this case, I can see that 28 and 20 have a common factor, and so do the 21 and 15. So what's the greatest common factor to 28 and 20? It is, well, 7 times 4 is 28, and 5 times 4 is 20, so it's a 4. And between x cubed and x squared, I can take an x squared out. And this leaves me with 7x plus 5. Okay, and then similarly, between 21x and 15, I can take a 3 out. So plus 3, you can factor that out. And this leaves you with 7x plus 5 as well. Now, when you kind of anticipate that this and that term are the same, you anticipate that, right? So now what is, how do we factor or do completely? Remember, factor completely. Here you factored, but you're not done. We want to go completely all the way. So then you write 7x plus 4. Remember, we said you would factor this out, you write it once, and then you write whatever is left, which is 4x squared plus 3. And this is your final answer. Now, if you write them in the opposite or different order, swapped, right, it's fine. You can do 4x squared plus 2, quantity 4x squared plus 2, multiplied by quantity 7x plus 5. So this is part, or number 2. Number 3, you have 2 terms. So again, 4 terms for number 2 was grouping. We're doing grouping here, right? For 4 terms, right? And again, you're not going to necessarily write this on the test, right? The key is your work and your final answer. That's what you get points on. Here you have two terms. For number 3, you can see two terms. And with two terms, we often associate that with the difference of squares. So I want to see if this looks like something squared minus something squared, a squared minus b squared, because we know from the difference of squares that this is going to be a plus b multiplied by what, a minus b. So let's see, is this the case? 16 squared is 4x quantity squared, minus 25 is actually 5 squared. So this is going to end up being, if I were to copy what I had here, it would be 5x plus 5 one time, multiplied by the quantity. 4x plus 5. I said 5x, I think. 4x plus 5, right? And then quantity multiplied by 4x minus 5. So again, one time plus, one time minus, okay? And that's just pretty much it, right? This is pretty much it, and you're done. And this is a special type of factoring. It's called the difference of squares. The difference means a minus and two squares, the numbers that are being squared here. Item number 4, or question number 4, it says, this is a traditional trinomial. And if you remember, this here is a 1. And when that is 1, when the leading coefficient, right, this is called the leading coefficient here. Then the 1, right, the leading coefficient, which is a equal to 1. If you forget, remember the general, or the standard form, I should say, of a polynomial is ax squared plus bx plus c, right? Of a quadratic polynomial. So this is 1. So in this question, you kind of ask yourself, what two numbers multiplied to negative 20 add up to 9? That's how it goes. This type of question, this is how you proceed with it. So what two numbers? Well, let's try. What two numbers multiplied to, any numbers multiplied to negative 20 add up to 9? If you forget, or if for some reason you don't know, what you can do, you can start with finding the factors of 20 or negative 20, which are 1 and negative 20, negative 1 and positive 20, right? 2 and negative 10, negative 2 and positive 10, 4 and negative 5, negative 4 and positive 5. These are the factors of 20 right here. These are factors of 20. Out of these pairs, or negative 20, I should say, negative 20. Out of these pairs, which one pair adds up to 9? Notice 1 and negative 20, or negative 1 and 20 are far apart, so there's no way they make a 9. And 2 and 10 also, they don't make a 9. Now we may think 4 and 5, but the thing is that here you have positive 4 and negative 5. They don't add up. These two add up to negative 1, and those two add up to positive 1. So none of them really adds up to 9. No, there's no two numbers that multiply to negative 20. Remember, this number here is the multiply, right? The multiply is on top, and add up to 9. None of them. So because of that, I cannot factor, and therefore we call this prime. Okay, this is a prime polynomial. That means you cannot factor it. Number 5, x squared plus 3x minus 40, same idea. What two numbers multiply to negative 40 add up to 3? Now, some of you may automatically kind of land on the correct pair of numbers, and some of you may not. But in either case, you can always resort to this method. What are the multiples of negative 40, right? Negative 1 and 40, 1 and negative 40, negative 2 and 20, 2 and negative 20, 3 doesn't go into 40, 4 and negative 10, negative 4 and positive 10, 5 and 8, 5 and negative 8, actually, to be exact, or negative 5 and 8. Notice the last one here, 8 minus 5, that's your 3. Okay, if you need more time, that's how you do it. So you get negative 5 and positive 8. So what are your factors? Again, because the leading coefficient is 1, it's automatically x minus 5. It's x minus this times x minus that. X minus 5 quantity multiplied by x plus 8. And again, box. Okay, so this is number 5. Number 6, same idea. What two numbers multiply to 72 add up to negative 17? I'm thinking of 8 and 9, but because the product, when the product is positive, that means both numbers you're multiplying are either positive or they're both negative. But because the sum is negative, that means they must be negative, right? So I'm thinking -9 and -8. And try it. -9 multiplied by -8 is 72. -9 plus -8 is -17. So here you get n minus 9 quantity multiplied by n minus 8. Now, if you wrote this if you wrote this as n minus 8 times n9, it's the same thing, right? Think about them as 2 and 3. 2 times 3 or 3 times 2. It's the same by the commutative property. Okay, number 7. So we're at number 7. Again, the deal was when you have a trinomial or any polynomial, basically, you try to find a GCF. Here, by looking at the terms, I can see that they have at least something in common. You know, they're all even, so I know that at a minimum they have a 2 in common. So how do I proceed, right? Now 8 and 20 and 200, not only do they have 2, they actually have 4 in common. So 4 is a GCF, and that's it. There's no letters, right, in common. So what is left? If I factor a 4 out, I'm left with 2x squared plus 5x, and then minus 50. Okay. So now I have to factor, I'm doing side work here. I'm trying to factor 2x squared plus 5x minus 50. So on the side, I'm going to try to find what two numbers, remember, what two numbers multiply to this times this, which is -100, and add up to 5. So if you think of 100, the list to multiply to 100 is 1 and 100. No, I want a -100, -1 and +100, 2 and -50, -2 and 50, and so on, right? 3 doesn't go into it. We talked about divisibility rules in class. How do I know if a number is divisible by 1, right? We covered that. 4 and 24 and -25, right? You can put parentheses, or actually, sorry, commas in between them. 4 and -25, -4 and +25. So all these multiply to -100. You can do 5 and 20, 5 and -20, or -5 and +20. These are the factors. 6 doesn't go into 100, 7 doesn't go into 100, 8 doesn't go into 100, 9 doesn't, and 10 does. So 10 and 10, right? 10 and -10, or -10 and 10 is the same thing. So any one of these pairs, these 9 pairs of numbers, add up to 5, because the middle term is 5. You always say what two numbers multiply to this times that, which is a -100, and add up to the middle term, which is 5, +5. 1 and -100, those are big numbers. So are 2 and -50 and -2 and 50. And same thing for 4 and 25. 5 and 20 still far apart. None of them really multiply to -100, add up to 5. So technically, you're done, okay? Now, here's the thing here. Here's what I want you to be careful with. You don't say that this is prime, number 7, because you could factor a 4 out. You took something out. Now, this did not factor after that, and that's fine. But previously, we did some work and we factored something out. So for this reason, we cannot call it a prime. Prime means from the beginning, you couldn't factor at all. Okay, that's what prime means. Moving on, number 8, same idea, GCF first. I see 15, 50, and 35. So I'm assuming 5. I think 5 is the largest number in common, and there's no n's in common. The first two terms have n's, the third doesn't, so it's just 5. And what's left is 3n squared plus 10n, and then plus 7. Now, again, just like I did with number 7, I'm going to do the same thing with number 8. You're going to find two numbers for number 8. We're going to find two numbers that multiply to this times that, to 21, and add up to 10. What two numbers multiply to 21? Remember, I call this in class the AC method, right? This is A, this is B, and this is C. I call it the AC. That means A times C, which is 21. And so this multiplies to AC, or this is the product of AC, and this is B. And the numbers are 3 and 7. 3 times 7 is 21. 3 plus 7 is 10. So technically, what are we saying here, right? Technically, what are we saying? We're saying the following. We're saying we can break this up here. Let's copy the 5. We can break this up, 3n squared into 3n squared plus 3n plus 7n plus 7. Remember the 3 and the 7, those are the breakdown of the 10n. So they're 3n and 7n. And I put them next to the 3 and the 7 because I can factor them out. Then this becomes 5 multiplied by 3n squared and 3n. You have 3n in common, so 3n times n plus 1. And then 7n and 7 is plus 7 times what? N plus 1. Let me clean that up. N plus 1. Okay. Now, because this is the same common factor, so I can again copy the 5 down. I can write this 5 times n plus 1, which means this is in common. Whatever's left is 3n plus 7. And this is really your answer. Okay. So that's this part. Let me see if there are more questions. I pretty much covered most of the potential review questions. Again, make sure you review, make sure you understand this well. Yeah, there are 2 more questions. Let's do them. So for number 9 here. Number 9, again, you're asking yourself, what 2 numbers multiply to, remember this times that, 9 times -8, which is -72, and add up, right, to the middle term. The middle term is there's nothing here, so it's a 1. So what 2 numbers multiply to -72 add up to 1? And we did previously 9 and 8, 72, but we want the product to be negative, but the sum to be positive. That means the largest must be positive. So it's 9 and -8, right? Now, once you have that, these are your x terms, right? These are your x's. This is the breakdown. Think about it. 9x minus 8x is your 1x here. That's what that is. So now you're replacing 1x by these 2. So how do I do that? I just go 9x squared, and instead of plus 1x, I'm going to put the plus 9x minus 8x, and then minus 8. And now you do grouping. Now it's easy to see grouping here, right? You can factor these out together, the 2 terms, which is 9x, and what's left is x plus 1, and then minus 8, and also x plus 1. And we're kind of anticipating that. So you write the x plus 1 once because you're factoring it out, and whatever's left is 9x minus 8. And you're done. Number 10, and the last question here, same idea as 9. I want what 2 numbers multiply to 6 times 20, which is 120, and add up to 5. So when the numbers multiply to a large number like 120, that makes it a little bit more, not more challenging, but more work, right? Because I want 2 numbers that multiply to 120, add up to 5. Sometimes you may get it, sometimes you may not, we don't know. So let's double check. If I go 120, 1 and 120, and I can do -1 and -120, right? Well, let me just start with the positives. I can do 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, 7 doesn't go, 8 goes into 20 15 times, I believe, or 120 15 times. 9 doesn't, and 10 and 12. And notice as we go through this list, the gap between the numbers shrinks, right? Look at the numbers between 10 and 12. So any one of these, whether positive, and again, they have their counterparts here, -2, -60, -3, -40, etc. Anyone, we don't need them really, the negatives. We're focused on the positive 5. Any one of these add up to 5. None of them, because look, I mean, the lowest is 1 and 120, so none of them add up to 5. So what I'm saying, I cannot find 2 numbers whose product is 120 and whose sum is what? Is 5. For this reason, and I couldn't factor anything out, they didn't have anything in common to begin with. So for this reason, I would call 10 what? Prime. It just did not factor out with me. It did not follow this rule. It didn't give me the 2 numbers that multiply to 120 add up to 5. There was nothing that does it. So that's pretty much it. So good luck on your review for this quiz, and make sure you revisit this video as much as you need to for you to master these concepts prior to the quiz. And best of luck to you.